moving on to shaded regions today, which is our last official lesson on our geometry unit. You can calculate the area of shaded regions today. That's what you can do. Here's the process. Find the whole area. Find the whole area. Find the unshaded area. And then you subtract. Some kids think find the big area, find the small area, and subtract. However you want to think about it is your choice. So we'll go ahead and start nice and easy. And I'm going to show you, I break this out. So I do my whole area is 12 times 5. That's this big one. 12 times 5, right? That's 60 square centimeters. I'm going to just deal with the centimeter part at the end. Now I got to find my unshaded or small. That would be 8 times 3, which is 24. And notice me lining it up like that makes it super easy to subtract. So the shaded region is you're going to take away this unshaded part and it will leave you with the shaded. So I found my whole, I found out how much this is, now I'm going to take it out. I'm taking it away. So 60 minus 24 is 36 square centimeters. That's the area of the of the shaded region. Okay, now bumping up the rigor with circles. Find the whole, which is 5 times 10. It's this whole rectangle. Now the unshaded, which is that circle. Anytime you're dealing with circles, it gets confusing because you have, especially with area, you have to have radius. So it shows me that this is 2.5, which I know is my radius. So this 2.5 is my radius. So the unshaded is 2.5 times 2.5 pi. Pi r squared, which is 6.25 pi. But it's not all of it, right? That tells me the area of a full circle. How much of a circle do I have? Yeah, so I actually have to divide that by 2. Oh no, I'm running out of room. Okay, and then you get 3.125 pi, which is 9.8. Darn it, I should have planned for more room. But that's my unshaded. So I found my first, I found my unshaded, now I have to subtract. So I'm subtracting 50 minus 9.8. 40.2 square centimeters. So I do want you to be able to know what you're subtracting. I'm subtracting my big area of this 50, my small area, the 9.8, and I get my final area of 40.2 square centimeters. Next one. I have a circle, we call it inscribed. A circle is inscribed within a square. That means that see how the edges of the circle touch the edges of the square? That's what we mean by inscribed. So I got a diameter of 12. So you have a big area or the unshaped, the whole. It's a square, so it's 12 times 12. Which is 144. Now my circle, or the small, I need an area, so area is pi r squared. So I need r. If all of this is 12, then r is 6. So it's 6 times 6 pi, 36 pi. 36 times 3.14 is 113.04. So my total area, you subtract this, take away this. So 144, take away 113.04. $30.96. Looks like it's inches. Now notice it's not that big, but do you see? The shaded part isn't that big. It's just a little area. So I found my whole area, I found the circle area, and now I'm pulling the circle out, and that leaves the shaded. Okay, next one. Let's see here. We got 6 is the dimension of the square. We got 4 is the radius of that circle. My big area here, this is a square inscribed within a circle. So my big area is circle here. So 4 times 4 pi, 16 pi, 50.24. My small area is the square, which is 6 times 6. You can't see your 6? Okay, make your 6 visible. It's right there. So, maybe I should have brought it up there. But anyway, it's too late now. 50.24 minus 36 is a total area of 14.24, whatever my units are. All right, the next one is definitely one that is a circle inside a circle. It's where you have to really think about radiuses here. So you have a big circle and a small circle. And then you take away the 2 areas. So big circle. I'm going to, because radiuses are the trickiest part here. My big circle has a radius of 10 plus this 1 for a grand total of what? 11. My little radius is just 10. So that's my first plan of attack. I figure out my radiuses because that's what kids mess up the most, is those radius. So now my big circle is going to be 11 times 11 pi, 121 pi. My little is what? 10 times 10 pi, 100 pi. Notice I'm going to deal with pi at the end. I like leaving pi just hanging on the side because it's like a variable. It's like terms. So now I'm going to go 121 pi, take away 100 pi is what? 21 pi? Mm-hmm. Now I calculate it. 65.94, what is this, meters? Square meters. Now let me tell you, some of you might calculate pi right here and right here. That's fine, your answer is going to be different than mine. The sooner you estimate, the further away you get from the actual answer. So we try in math to estimate as late as possible. Because once you estimate here, your answer's off. You estimate here, your answer's off. So you're going to get even more off than if you estimate at the end.